there's my u, there's my du, I see it, okay? You should start seeing functions that way. If I have to do an antiderivative, no problem. It might help to visualize this or for you guys to graph it. Okay, so we have x equals 1, vertical line at 1, y equals 0, which is going to put us in one of 4 regions. We're either over here, over here, over here, or over here. I don't know which one yet. If you graph x e to the x squared, I think it looks something like this. I mean, like it gets really steep really fast, and this part of it comes backwards and does the same thing down here. The only part of this that is actually bounded is here. Every other region goes on forever. This little region goes on forever, that little sliver would go on forever. Every single part of this thing is unbounded except for that region right there. So mistake number 1 was that people did not latch onto that, although I think y'all did a really good job on this one. Then to find the area, that's 0 by the way. So area is going to be from 0 to 1 of that function. Pretty straightforward. This is a teeny tiny u sub problem. U is going to be x squared. That'll make du 2x dx. We don't have a 2, but that's easily remedied. 1/2 du equals x dx. So if I do that little swap out, I'm going to get 1/2 antiderivative from, well, e to the u. Okay. Again, you have options to wait and then flip it back, or this one works out nicely because if you plug in 0 or plug in 1, you get the exact same numbers. So you would have gotten lucky on that. So 1/2 e to the u from 0 to 1, which is, okay, if you stick, is that hard? Yeah. If you stick in 1, it's e, or e to the first. If you stick in 0, it is not 0. E to the 0 is 1, which I believe is just a fancy way of writing c. E minus 1 over 2. Now, calculator junkies. Here's what I bet you did. Type that in, got a decimal. Then took each of your 5 answer choices and plugged them in until you found the decimal that actually matched the answer that you got. Is that kind of what you did? Works for me. Okay.
I don't know where I did.
Did you get it right?
I think I like circled on one. I must have.
It doesn't seem like a bad problem, so yeah.
Actually,
I think you may have gotten the top and bottom either mixed up. That's why you have the minus signs in order, or you just saw the e and the 1 and circled
Because
out
I did the first one and then the second one I was like, okay, this is reverse. So then the next one, and I think we got it wrong, or I don't know. I think I switched it up or something. I don't know what I did.
I'm going to chalk that one up to a brain fart, and you knew what you were doing, and by the time the AP rolls around, we won't do that again.
Yeah.
Right.
Because I had the right answer. I just.
Number 10, by the way, number 10 is exactly like number 7. Oil is leaking from a tanker, find the amount that is leaked out after 10 hours. It's the exact same problem. So I'm going to do the antiderivative, 10 hours, so 0 to 10 of 500 e to the negative 0.2 t. Excuse me.
If you just match C and mark C and moved on, you would have been pretty
On
well.
this one, you'd have done quite well. Yeah, both front and the back, I think, had some C answers.
Yeah, they're pretty good C's.
Which is, I have no idea, but it's somewhere in the 2150, is that right? 2140?
Front had no C's.
2160.
You would have failed the front page if you marked C.
Again, notice how close these answers were.
You marked C for the calculated on top.
No, I did.
There was one C,
C.
at the bottom.
Oh yeah, I just got that wrong.
Then we get to one of my favorites, and this is the particle motion. You people have got to master particle motion. The relationship between position, velocity, and acceleration. Position, velocity, acceleration. Okay?
That's
Also, my kids last year were retarded because they do practice tests and they'd be going, and I know what they were doing, and they were position, velocity, acceleration. Whatever works, man.
We're
Whatever
just
works.
chanting the Colts.
Yeah, right, yeah. Calling down the gods. Here's what we know. That the velocity is given as t over 1 plus t squared on the interval from 0 to infinity. They also give you the initial condition that the position at time 0 is 0. So when t is 0, the position, or at the origin is what it said, which is 0. Let me talk algebra before we get to the calculus. Some of you tried to expand this, okay? You can, by the way. It honestly works out better if you don't. But if you did, if you were one of those people, here's the wrong way to do it. Okay? That's not how the square actually works. And I'm speaking to both classes, like you, fourth, and Green C. Because there were a couple people across the board that butchered that. That's not how distribution of a power works. Okay? If you were to expand it, it would look like this. Okay? That's how it would have worked.
They missed the one part.
They lost the middle part. And it's best, again, write it as 2 parentheses and then distribute it if you're going to do it that way. If you write it this way, it messes up U sub, which we're going to need to do in part C, I think. All right? So it's better to leave it the way they give it to you. Now, if you wrote it like this, part B, where they want you to find the acceleration, works. It's bigger, nastier, but it still works just fine. For part C, though, not pleasant. All right, part A. Find all the times when the particle is at rest. How do we figure out where a particle is at rest?
When the velocity equals 0.
Thank you. That's exactly the way you should say it. When the velocity equals 0. I have kids.
That's how I said it in my head.
Right. It's not this. Don't say when the derivative equals 0. Because it could be which derivative? Okay, so velocity is specific. First derivative, got it. And if you say the derivative equals 0, then some people start by taking a derivative. But we don't need to because we're already given velocity. So if you wrote this, that was worth the point. Just telling me, okay, I know I'm supposed to set the velocity equal to 0. Got it. Now, it's a fraction, and fractions equal 0, and their tops equal 0, and the only place that t equals 0 is if t equals 0. So your answer for this one was t equals 0.
So when you did the math and all that, it was.
I have no idea what you were doing, but
I know, I just plugged the calculator and I'm like, this doesn't need.
right. And if you just, by the way, because it's a calculator question, if you just type that in, I don't know why you would waste the time to do that. If you just wrote t equals 0, that was worth both points. Okay.
I was like, well, I
If you didn't get this right for some
There was
reason,
another thing.
Didn't get that right.
if you didn't get this right, but you wrote this, you still got 1 point for knowing that's what you're supposed to
I
do.
was like, it's gotta be just.
All right, part B. Was this the acceleration question?
Yeah, I got
All right, find the acceleration. Got it. Acceleration means
derivative of velocity.
derivative of velocity. You don't need to write this unless you just want to remind yourself. I would suggest, however, that when you're doing this, that you use the notation A of t and not necessarily v prime. You're not going to get it wrong if you write v prime, but in our brains it kind of works better with s of t, v of t, a of t. All right? Or x. Sometimes they like to use the letter x here. That gets, I get it. They do it because they say a particle's moving on a number line, and you're telling me which x he happens to be at. That's a position. I get it. It does get a little confusing though, because y'all are used to an x being a variable in a problem and not
Shouldn't
a.
be y because at that point it.
No,
T
if
is-
you're thinking number line, if your t is your variable,
Oh.
I'm at this x, now I'm at this x, now I'm at this x. It depends whether your number line is doing this or doing that.
It doesn't matter.
I like s for position.
I just think y would be better because you already have your t as your x pretty much, so y would, and then having an x, you get mixed up because you think of it as your variable.
Right, yeah. Here's what you don't want to do. Don't make up your own letters. If they have called it S in the problem, call it S, okay? If they're using t as a variable, you use t as a variable. Do that. So let's see, I'm gonna have to do derivative, which is a nice quotient rule. Low.
D-high.
Now let me just mention this for anybody that happened to forget the quotient rule. Low. Low.
D-high.
D high.
Less
High. D low. All right, D low. This is a chain rule.
Two thing.
Thing to the first. And then we chain the inside, which gives us an extra 2t, all over the bottom squared. So 1 plus t squared to the fourth. If you stop here, that is 100% right, you get full credit because it is the acceleration. Done. If you clean it up,
Like me, and be an idiot.
you get something wrong, yeah. If you clean it up, I think it ends up being, let me check this, but I think it's 1 minus 3t squared
Oh, I didn't think that.
over 1 plus t squared to the third. I think that's right. Yeah. By the way, first thing I would do,
Yeah, they cancel out those.
first thing I would do is notice that we have a 1 plus t squared in everybody, so I would cancel this out, one of these, and one of those, and then distribute combined like terms, blah, 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 and it will turn into that. If you stop here, however, you get 100% credit, because it is a derivative.
And that is, it's not the prettiest, no one likes you, everyone would like to use the cleanup version.
I mean, even, honestly, let's say they wanted, okay, if they said, what is the acceleration at time 3? I can plug 3 into this, it'll be a little while, but I got a calculator, why not, you know? So,
I like to plug through into that, but.
me as a mathematician, I love to clean it up. I don't know why, it's just, I mean, I know why, but we like them clean. Most of the stuff, you know, except for calculus, the math that high school kids learn has been that way for thousands of years. We haven't really done anything that new with high school math except try and make it cleaner, that's it. All the new math that's out there, that's well above what high school did ever learn. All right, part C, find the position. All right, this little guy right here is gonna come back with a vengeance in this problem.
Pretty.
But in order to get to position,
Guys, you anti.
start with velocity and work backwards. So our position function, s of x, I'm so sorry, s of t, lost point
Which
there.
is why the anti doesn't work well if you multiply it out.
Right, yeah, because you don't see the use of that you're supposed to use. We don't really have a starting point and stopping point, so I'm gonna have to do a plus c on the end of this, and that's why they gave me that, is to help me find the plus c. So t over 1 plus t squared squared dt. Okay, relatively simple use of. We're gonna let u be 1 plus t squared. Get down here. That's gonna make du 2t dt. We don't have a 2 in the problem, so 1/2 du equals, excuse me, t dt. All right, there's my u sub scratch work. So I get 1/2 antiderivative of 1 over u squared. Or 1/2 antiderivative of u to the negative 2. Okay. Antiderivative, raise the power 1, we get -1, so we divide by the new power, and we get -1 over 2u. It's a combination of the 1/2 and the u to the -1, and then don't forget your plus c.
You said you could solve, but if you're stupid, you don't want to solve for it.
Which gives us -1 over 2 times 1 plus t squared plus c. Now, that got you the bulk of the points. I think that was worth like 3 points if you got it that one. The last point, well, all of it would have been worth 3 if you'd done it right. Now we have to find c, and in order to do this, we're going to use our initial condition that s of 0 is equal to 0. So, scratch work over here. S of 0 is going, I need more room than that. S S of 0 is going to be 1, -1, over 2 times 1 plus 0 squared plus c, and that's supposed to be equal to 0. So you end up with -1/2 plus c equals 0, so c equals 1/2. My final answer, therefore, is S of t is equal to -1 over 2, 1 plus t squared plus 1/2. That plus c, finding plus c, we haven't done a lot, we've done some work, not a lot of it. That's a huge factor in the latter part of this class. Right before we hit the finish line, our very last unit, that's almost exclusively what we do is work on finding c, okay, and all the intricate ways to do that. Ladies and gentlemen, calculator. I thought this one was one of the heavier calculators, like you really couldn't do some of these without the calculator, whereas in previous tests, you were able to kind of finagle it if you didn't know. But number 7 and number 10 were impossible without a calculator.
Number 6 was helpful. A lot.
6 was
You
way
could-
more time consuming without one.
Yeah.
8 could have easily been done. In fact, the calculator is what led you wrong on that one, for those of you that didn't set it right. And this one, the only thing that was bad about this was that our answer choices were technically in hand mode, not in calculator mode.
But you could. So.
But it was, yeah, easy to type that in and see what you get. All right, I'm gonna need them back to put final scores on for whenever Shannon gets finished, but I hope you made corrections, I hope you pointed out to yourself the things that you need to fix, okay?
How stupid I am.
And notice, I don't know if y'all are working continuously on your requests, but a lot of the mistakes y'all are making here, I try and pick problems I know you're gonna screw up on so that it's helpful for your requests, all right? So each week, there's a reason that I pick the questions that I do. I am excited about next week's quest because we can use some of this new material that we're doing and it is super awesome. All right, Amber, Michael, Rayana.
When's the last time we had a full class?
Last week sometime. Tuesday maybe? Something like that.
So
Going on a week now.
yeah.
Yep. Remind me to leave these in here for the other two, for Jerry and Edward to look at. I need these back, if you're watching the video, I need those back, by the way, if you leave them in here. Okay, cleared the slate, everybody got what they want? I think it was yes. Great. We're gonna grab Shannon so she can come and listen in. So, let's see if she's ready. Today's exciting lesson. It's a 2-day one. Oh, new lesson, new homework sheets.
Yay.
I think I have new homework sheets. Yep, I do.
You had circles?
I keep them with me at all times. I can shove it in people's faces. You're in a circle. All right, one for Chelsea and 2 for All right.
You should make the first quadrant, so just hand out, every time someone gets it wrong, just hand them the first quadrant and say, this is pretty much all you need.
That's what I do. All right, we're gonna start with area between curves.
Ooh. So like, two things, like two different things, like,
Right.
ooh.
Yeah, it's a super easy concept, and it's more, we'll talk about the concept, and then you go, that's child's play, and then we'll do a couple practice problems, and that's it. tomorrow's lesson, we're gonna do more of this tomorrow, and it gets a tad bit more detailed with them, but it's the same concept. So, let's look at the evolution of your area experience. So, back in elementary school and middle school, y'all learned your man-made shapes, your rectangles, your triangles, circles, and everything that went along with it, like a trapezoid and a parallelogram and all that other cool stuff.
I don't think we could learn parallelogram until like first grade.
Until what?
Until first grade.
I don't know, elementary school, middle school, it's been a while, okay? But that was your journey through geometry at that point. And then we hit, you know, I won't say weird shapes, but then we evolved into the ones that were like combinations of other shapes.
Oh.
And you learned how to slice them up. You were basically breaking it down to the shapes you already knew, okay? And cut and paste and do all that kind of stuff. Then we got to calculus.
It's pretty far shown.
Well, it's pretty much, you stagnated there for a very long time, you know. And then we hit calculus and we started looking at areas of things like this. And honestly, we did the same thing. We turned it into a bunch of rectangles. We did everything we had done before. We tried to break it up into shapes. The difference here was that we made our rectangles infinitely small so that we, you know, created this curved shape, but it was basically a rectangle for the most part. Now, this is what we're okay at. One curved side, and then we got these other three flat edges. Okay. Today, we're gonna go kick off the training wheels, okay, and look at stuff like this. So, I have function 1 of that f of x, function 2, okay, call that g of x. And I would like to know what the area is enclosed between these two graphs. So let's say we chop it off here at A, and we chop it off here at B, so that we're talking about this area right here.
Okay. Sounds simple.
It is, it's extremely simple. And when you see it, you'll go, well, duh, that's where it goes. So we're looking at stuff like that. Now notice we're still cheating a little bit. We still have two flat sides. Well, we got two curved sides. That's twice as many curved sides as we had before. All right.
And you just make it so the graphs, if they intersect, then
Okay, now we're that's phase 2.
Then there's no straight lines.
Yeah, which we will look at today. It's not that bad. We'll look at it today. All right. So in theory, let's talk about what's going to happen here. Well, you know what, I've done problems kind of like this before. So in theory, it's pretty simple. We'll find the area of the top function.
And then we subtract.
And find the area of the bottom function, then we subtract it out. That's it. Okay? So in general, if you're a formula junkie, and your area between curves is going to look like this. We'll go from A to B, whatever that is, of the top function minus bottom function. And I'm going to write it like this because while in my picture f is on top and g is on bottom, that could easily be switched, or like you said, somewhere in the middle, they might trade places. Okay? But as long as you stick to this theory right here, top function minus bottom function, you won't go wrong. And honestly, if it does cross over, that's an easy fix. We'll just do one part of the graph where this one's on top and this one's on bottom, and then we'll do a second part of the graph where this one's on top and this one's on bottom. So in theory, it's very, very straightforward. All right. Put a box around it. It is. It is. Today's not the hard one. Today is just doing some practice problems to get this straight. Tomorrow, when we start doing area this way instead of this way,
Okay.
just gets a little funny.
Okay.
Okay, function 1, f of x is equal to x squared minus 4x plus 10. Make sure I'm doing this right. That's the wrong section. And g of x is equal to 4x minus x squared. Yeah.
Getting fancy with
It
this.
is. And I want to do this on the interval from 1 to 3. Now, I'm going to way overkill this question. Homework sheet for the next one. I'm going to way overkill this question because I think it deserves it. And if you can do this in the way overkill fashion that I'm about to show you, then you can do any function or any sets of functions at all. Okay, technique number 1. You can graph it and see which of those functions is on top and which one's on bottom. By the way, don't assume that because I gave you f first, that f is the one that's on top. Don't do that. Thoughts?
Well, one's an upside down parabola, one's a parabola.
Correct.
So, depending on where they are, you just easily.
Depending on where they are. You have an upside down parabola, and you have a right side up parabola, whatever.
I'm gonna,
So look at all the things that could be happening.
ooh,
In which case, we'd be looking at that area.
yeah.
Or, in which case we're looking at that area. Or, something like this. But the zone they want is like this. Let's say this is 1 and 3. Now we're looking at that. Okay, so lots of things can go screwy. Or, you know, like these two could just tangent, barely touch each other once, but in which case you're still kind of dealing with this situation right here. So even though this question is relatively straightforward, I'm going to overkill it by asking these questions.
Where they intersect.
Which function is on top, which one's on bottom, and does that ever change? Okay? We're going to answer the second one first. Does it ever change? You said, see where they intersect. That's a very smart thing to do. Let's see where these two guys intersect.
If they do it all.
All right, if they do at all. So the first thing I'm going to test is intersection points. By the way, even if they do intersect, there's no guarantee that it intersects somewhere in the zone between 1 and 3. We could do all this great work and find out that they meet back there at -2, and then it didn't do us any good anyway. All right, so intersection points. This would honestly be where a calculator really shines, so on a calculator part of the test, you better believe I'm graphing those two things, okay? So, how do I find intersection points? Okay. Yep. Seriously?
Set them equal to each
Set them equal to each other. Yay, when do they equal each other? X squared minus 4x plus 10 is equal to 4x minus x squared. Oh my word, that takes me all the way back to algebra 2.
I don't remember algebra 2.
You had a horrible teacher then. Anybody know what we do from here?
Yeah, solve.
Okay, good use of that word. Now, do it. We just solve it, duh. Quit wasting my time. You might want to fast forward through something. Factor? Not quite.
Yeah.
Anytime you have,
Oh, yeah, you can just. you can
yeah,
just
set
combine
equal to
that
0, get all the crap. Okay, combine like terms, that came up at green C. You can't combine like terms like this, because you have stuff on this side of the equals and stuff on this side of the
Well, I
equals.
mean, like, yeah, just have to add it all over there.
Right, get it all on one side, and we can combine like terms. Okay, if I bring the x squared over, I'm going to have 2x squares, negative 8x's, and 10.
Lovely 10. Now,
Now I can try GCF, AC method, stuff like that. I see a 2 in common, so I'll factor out a 2. X squared minus 4x plus 5.
great.
Okay, 2 is irrelevant here, because when I divide both sides by 0, it doesn't really hurt, or divide by 2, it doesn't really hurt anything. That's a good old AC method. My leading coefficient is even 1, makes it even nicer. I need factors of 5 that add up to -4.
Ooh. It's not good.
Well, I picked this one for a reason. A lot of people. Okay, most common wrong answer, 5 and 1. 1 times 5 is 5, but 1 plus 5 is 6, not -4. So if we try 2 negatives, 2 negatives will still give us a 5, but when you add them, you get a -6, still not good. So the third wrong answer is to try a -5 and a +1. A -5 and a +1 will give you a -4, but it gives you a -5 on the end, so thanks for playing, none of it worked. This does not factor. Here's the bad news. That doesn't mean that they don't cross. That just means they don't cross at a pretty number. Okay? So, we might want to try some AC method, we tried factoring. Either complete the square or quadratic formula.
I like quadratic.
Quadratic formula? Alright, what's the quadratic formula? Just finish your sandwich.
I did.
Alright.
I don't want to talk my mouth full.
Go ahead.
Okay, -b plus or minus the square root of -b, or is it just b?
B squared.
B squared,
Just B.
isn't that-
Honestly, it wouldn't matter
It wouldn't
if you're
matter,
squaring.
because we're squaring it. Minus 4ac all over 2a.
Very good, you were awake for 10 minutes there.
Okay, that's my math for today. Just getting that for my test.
Alright, go. Well, these are irrelevant, let's fix the inside up.
Yeah, 20.
16
minus 20.
minus 20,
-4. Ooh,
stop there.
that's a-
Why?
It's an I.
Because you get an I, which
It
means
doesn't cross.
they don't cross. Good,
Yes.
alright, so we're gonna get something with an I in it. Sad face. Okay, so that part right there ends up being -20.
Does I actually equals?
I'm sorry, not -20, -4, I think.
Does I actually equal sad face?
Do what?
Does I equal sad face?
I equals sad face, yeah. So we don't get any spots where they cross. That's not a big deal. All that means is we don't have to break this up into multiple regions. Whatever the area is, whoever's on top is always on top, and whoever's on bottom is always on bottom. So no crossover. We did all that work to figure out that we don't have that much work to do.
And I have a way to figure out what's on top, what's on bottom.
Do tell me.
Let's just plug in a number.
Very good, okay? That's exactly how you should be doing it. So now area. Who's on top? Wasn't that an Abbott and Costello act? Who's on top?
Sounds like funny.
Who's on first is there?
Yeah, who's on first is there? Who's on first? What's on
Yes.
second?
I don't know who's on third.
Who's in the outfield?
No, who's on first? See?
It's great.
It is good.
Almost like the baker dozen.
Who's on first? Yes. Who? Who's on first? Yeah.